Okay, let's go directly to here. Give me 1 second here.
Supposed to be, but now it will be. AWG. Okay, suppose guys I have a panel like this, and I'm taking a conduit, 3/4 of an inch. I'm taking a 3/4 of an inch conduit. This is 3/4 of an inch conduit. EMT. EMT. I'm taking a 3/4 of an inch EMT conduit, and I'm pulling 16 conductors number 12. 16 conductors number 12 in there. Can I do that fill-wise? Yeah, if you go do the fill calculation, you can. They're all THHN. All the conductors are THHN. 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 And I want to see, there's, as I said, 16 of them. 16, if you can imagine, this is 4 three-phase circuit like this, three-phase circuits. Can you guys see what? This is basically 4 of that circuit that you're looking at. Can you imagine that? Everybody can imagine? If you put the 16 conductors, these are 4 circuits, 3-phase each with shared neutral. Common, we use it commercial all the time. So you're sharing a neutral. The voltage is 277 to neutral, or 120. It really doesn't matter what the voltage is, 120 or 277 to neutral. Okay, everybody can see the scenario is I took a 3/4 of an inch conduit from a panel all the way to a J box right in the ceiling, and I filled that conduit 3/4 of an inch with 16 conductors number 12. Can I do that fill-wise? Yes. If you guys go to the conduit fill EMT, you can find that's the max that you can put there, 16 number 12, right? And Chris is nodding his head indicating yes. So what am I going to do with these 16 conductors? I don't pull conductors for the sake of pulling conductors. I am taking 3-phase and neutral to feed receptacles and or lights, depending on the voltage. If the voltage is 120, it could be receptacles and or lights. If the voltage is 277, 99% of the time you're feeding lights. So the voltage really irrelevant. The voltage is irrelevant. Okay, everybody see what we're doing? And we're putting a 20 amp circuit on each one of them. These are 20 amp 3-phase circuit breaker or 20 amp single pole circuit breaker tied together with an approved handle, as it should be when you share neutral. All these are multi-wire branch circuit sharing neutral, 3-phase and a neutral, 3-phase and neutral, right? Cool? Okay, what the question is, this is the rating. So let's see. Now it's a 20 amp circuit. How much can I pull out of this 20 amp circuit? How much can I pull out of this 20 amp circuit? 20 amp circuit through these conductors. There are 2 ways. Number 1, guys, I already decided to use number 12. I'm not changing conductors. I'm going to use number 12. So I need to know how much current can I pull out of number 12. Okay, so the first thing you need to do is number 1 is find the load. The load. Find the load. How much current can I pull out of these circuits, of each circuit under these circumstances? Would that be a good idea to find how much under these circumstances I can pull out of these circuits, right? Okay, so the first thing we need to know, this is 3-phase commercial, so the load is considered continuous load. Let's say they're feeding lights, the lights are considered continuous load. If you have a continuous load, how much current you can load, the circuit breaker, how much amp you can pull out of a circuit breaker continuous load? What's the percentage? 80%, thank you. So we start by saying overcurrent protection device equal 20. Because it's continuous, I am limited to then load equal 0.8 times 20. What would that give you guys, 0.8 times 20? 16 amps. So from the get-go, I'm limited to 16 amps because it's continuous load. Light, continuous load, right? I'm limited to 16 amps on these. So what does that mean actually? When you start circuiting your lights, here's 1 amp, assuming each one of these lights is an amp. So you can only put 16 lights on that circuit breaker. Piece of cake, right? assuming that each one of them is 1 amp. If it's not 1 amp, you do your math. Take the volt amp divided by the voltage, get you the amps, and add the amps. You shouldn't add up to more than 16 amps on every one of them, on every one of the single pole 3-phase circuit. Any question, guys, about this up to this point?
What about the number of...
Thank you. We're not done yet. So that's find the load based on continuous load. My load, based on continuous load calculation, my load should not be more than 16 amps. Everybody agree on that one, at least? Everybody agrees on that one? Based on continuous load. My load cannot be out of this circuit more than 20 amps. Okay, cool? So I'm limited to 16 amps from the get-go on this circuit breaker. Okay, now my problem is I decided to group them together, put them in a conduit. So I have another issue. What's the other issue? Grouping, bundling. Okay, so I have a bundling problem. Let's go do number 2. We need to check with bundling. Number 2. So bundling conductors, and that will be derating. We need to derate. Okay, so let's go derate. I am using number what? Number 12. T, H, and H, and N. And if you guys take this one to 310.16B, oops, 310.15B16. 310.15B and a 16 under 90-degree column. Anybody can tell me why 90-degree column? We're derating. And it's THHN. How much current can I get out of number 12 THHN under 90-degree column? Why did I go to 90-degree column, guys? Because it's derating. Okay, so what do I get? If you guys go there, you're going to get, this will give you 30 amps. Am I right? Everybody got 30 amps, right? Under 90 degree. Okay, so that's 30 amps. Next, because of the 9, is it 9 or 16? Oh, by the way, since I have 16 conductors, and these 16 conductors are 3-phase and a neutral, and these are neutrals are feeding lights, and lights have electronic ballast in them, and electronic ballasts are harmonic offenders. They generate harmonic. So long story short, I have to count for the neutral here. I have to count the neutral. Why do I have to count the neutral? Because I'm feeding lights, most likely, or even receptacle that feed laptops and everything else. So worst scenario is the neutral have to be counted. Cool, everybody knows why we're counting the neutral. So these 16 conductors are actually 16 carrying current conductors. All of them, the neutral and the hot, because of the harmonic. So that I have 16 current carrying conductor. If you take this one to 310.15, which table is that? 15, B3A, B3 and A. What is the derating factor for this? 0.5, 50%. My derating factor is 0.5. The last thing to do is derated load out of this conductor is actually 0.5 multiplied by 30. And if I still have my brain, that will give me how much? 15 amps. How many amps have I lost because of bundling? 1 amp. When I bundle them all together, how many amps have I lost? Only 1 amp. Remember, this is the scenario. This is you can't go more than 16 under no circumstances because it's continuous load. So if I end up with 17, can I use 17 out of it? No, 16 is a max. So 16 is my max. Because of derating, I end up with 15. So which one am I going to stick with? The lowest, 15. So 15 amps. So now, Ashley, what do? I count 1, 2, 3, 4, 5, 15 fixtures, an amp fixture, a 1 amp fixture, and stop. Done. The reason why I like this example, guys, because this is very common in commercial industrial. Give you an idea the power of grooving conductors as they come out of the panel. So yes, we put 16 carrying conductor, we cut it by half, but we still got 16 amps out of number 12, 15 amps, which is Great, because I only can pull out of the whole circuit, every circuit, 16 amps. So I lost only how many amps? Only 1 amp I lost. Okay. So let me do this with the calculator. The challenge with the calculator, guys, is it doesn't calculate the amps. It always calculate. It doesn't calculate. How am I going to say that? Yeah, it doesn't calculate amps. It calculates conductors. You need to give the amp, give the load to get the conductor. That's what the calculator does. You have to give it the load to get the conductor. Okay, so let's go give it the load. I need to carry. If I want to stick with the 16, let's do it based on the 16. See, remember, no matter what I do out of this design, no matter what I do, I can't carry more than 16. So I know what my load is. I will start with my load. My load is what? 16, no matter what. My load is 16. So let me just go tell the calculator. Remember, I'm going to use the 16 and tell the calculator, size me a conductor that's going to carry a 16 amps if I bundle 16 of them in one conduit, 16 amps. And then I'm going to ask the calculator again to do 15 amps to see if we can get up. Now, Phil, my friend, if I ask my calculator right now to give me 15 amps, what do you think the answer should be? Number 12. The answer should be number 12. So let's start with that assumption. So take this. So load equal 15 amps. I decided to pull just 15 amps out of that circuit. Load equal 15 amps. Size conductor. Size conductor, knowing that there are 16 carrying conductor. These are I know that there's 16 of them, and I decided I will use 15 amps. I want to see if I ask the calculator, I need 15 amps. Would I end up with number 12? I should end up with number 12 conductor. Let's go ahead and do it. And they will size based on 16. Okay, the first thing I want you guys to do is switch your calculator set to 90. Okay, everybody got that one? Everybody set their calculator to 90. So I'm set to 90 copper. Copper is of default. So set 9 will set your calculator to look at the 90-degree column for insulation, which is theater channel. Cool? Everybody's okay with that one? Everybody set that one? Calculator set to 90. Set 9, set to 90. Now let's go tell my calculator what's the load that I need. I need 15 amps. Here's my 15 and hit the amps. Does it matter what the voltage is? Irrelevant. Irrelevant of the voltage. 15 amps. Cool? Everybody's okay with that? So set to 90. So my insulation is THHN 90. 15 amps. We're sitting at 15 amps. The second thing I need to tell them is how many carrying conductor actually I have 16. 16. Now you hit the 16 and then you're going to go set size conductor. So hit 16 and then hit set and size conductor. And your conductor is going to be what? Number 12. As it should be, right? Number 12, as it should be. Number 12. Based on the 15 amps. So my conductor based on this calculation, as we improved, is number 12, AWG. Okay? Any question guys about this? Now let me tell you how we're going to change that one. Any question about this? Yes, sir. Okay. Can you verify that your calculator right in here is 90 degree?
Yeah.
And did you 90 degree? And did you put 15 and hit amps? And did you hit set, and then went directly to the this button? And you got a wrong answer. Anybody else? Let's do it one more time. Let's do it together. Clean your calculator. How about go back here? Cool. Do me a favor. Were you doing setting the ambient temperature with us yesterday? Does it say amp in your calculator? Okay, now you guys are screwed up. Remember I told you yesterday? If you change the amp, you're sizing based on 50 or 60 or whatever. Let's go reset your calculator. Always. When you change the amps, it screw up your calculation. So do this with me, will you? Go hit set and hit clear or X. It's clearing your calculator. you should see the following. Only what I can see here. NEC 2011, 3-phase 60 CU. Everybody see that?
Yeah.
You shouldn't see anything else. And what happened is you're still calculating based on 50 ambient temperature that we did yesterday. Okay, cool. Now let's do it. Let's go do 15. First, change the temperature. Set temperature to 90. So now, Dustin, my friend, I changed this one to 90. Should be 90, right? All right. Then go to your 15 amp. I want a 15 amp. These are my loads, right? This is my 15 amp. Hit amp. Cool. Then how many conductors do I have? I have 16. Hit 16. And now I want to size based on 16 carrying conductor in a conduit. So you need to go set and access that DR size, which is size based on the rating. And what do you get? Number 12. Cool. But you see what the issue was? Your ambient temperature was screwed up. So please, every time you mess with the ambient temperature, clear your calculator by going set and X. Always clear the calculator back to the default.
What do they use DR size?
The rating size. DR, yeah, I know R is the resistor and D is distance. It's not a good combo. It's a derating size. This their lingo. Any questions about that? Any question about this? Now, my friend,
We didn't have to tell it what kind of insulation.
you did by doing the set 90.
Oh, okay.
Yeah, you did. You already did that one by telling a set 90. Care less about the time.
One of the.
Yeah,
the
one of the 90s. Now, tau, my friend, suppose I want 16 amps. I cannot live without 16 amps. I don't want to sacrifice that 1 amp, right? So how are you going to be as a designer thinking, suppose I want to just complete 16 amps. So I want, here's my 20 amp circuit. I want to pull 16 amps out of it. And I am not going to, why 16? Because that's the max I can pull continuous load. 16 amps. Go size this conductor for me, Chad, based on these circumstances. All what you have to do, guys, now, just hit 16 amps, because your calculator still set up the same thing, amps, right? And hit 16 again, and set conductor, and derate. What did you get? Number 10. Number 10. So Phil, my friend, for 1 amp, it pumped you number 10. 16 conductors went to number 10. Is that a good idea? I can sacrifice 1 amp. Does that mean I picked this example? I always pick it up, guys, because the importance of if you do your math, that's why I started doing it by hand to get you an idea. If I lose 1 amp, it's okay losing 1 amp. Okay, I lost just 1 fixture versus add 1 more fixture and all your conductors change to what? Number 12 and number 10. And guess what? You can't add another fixture to it, by the way, because if you add another fixture, it becomes 17 amps, and you're limited to what? 16 amps, no matter what. Oh, thank you. And it wouldn't fit in the conduit either. Yeah. When we say 10 now, we're assuming you're going to get a bigger conduit. Any questions about this? Everybody can see the importance of that? I always like to throw this example. Okay. Now let's take a couple of one more example, guys, about the rating, both temperature and ampacity, and that will be example number 2. I have air handling unit. You guys have a problem with that? Air handling unit. And I have my panel. And from my air handling unit to my panel, I'm paralleling conductors. I put my took, and excuse coming from the right. You don't come from the side of the panel, you come from the top. Let's do it the right way. Hate doing it coming from the side of the panel. So let's grab my panel and come out of here. Here's my panel. Inside this system, I have 1600 amp. I have 1600 amp circuit breaker, sized it. 1600 amp. You know what? Because this is an air handling unit, it's going to change my calculation. So I don't want air handling units because we do them differently. So we don't mess around. We're already messing around here. Let's do this. Let's use this panel. One panel feeding another panel. That would be more appropriate. This is 2000 amps. And this is 4000 amps. My circuit breaker here, what do you guys think the circuit breaker would be? 2000 amps. So I have a 2000 amp feeder feeding a 2000 amp panel. Okay? 2000 amp feeder feeding a 2000 amp panel. So out of this, I need to pull all the conductors that's going from here to feed that panel, hot, neutral, and ground. All my conductors. Long story short, find me a conductor can carry 2000 amps. Find me a conductor that can carry 2000 amps. You can't. So let's go parallel. So sizing, find a 2000 amp feeder conductors. Okay. The first thing you need to do, take the 2000 amp, divided by, like we did yesterday, 10, get you 200. If you take the 310.16, 310.15 B16, right? 310.15 B16 under 75-degree column. That will give me number 3 out. Did you guys come up with 3 out? Yeah. Like we did yesterday. 3 out. So that'll give me 3 out. 3 out. How many sets? 10 sets of 10 sets of number 3 out. How many conductors? 4 each. Right? Okay, let's go size the conductors. Make sure that we can get what we have based on my calculator. I want to remind you guys, we're going to go reset everything. So go set to 75. Before we start, Dustin, make sure it's 3-phase 75 copper. 3-phase 75 copper, right? Okay, grab your load. What's my load? 2000, 1, 2, 3, 2000 amp, right? And I need the wire size. So hit the wire size until you knucklehead. You can't find a conductor like this. So you need to parallel. So what do you do when you parallel? I decided to put 10 of them. Hit 10 and then hit the term parallel. And what do you get? 3 out. Everybody got 3 out from the calculator? 3 out. Okay, now I'm going to make it more interesting. I'm going to put all these 10 runs in one conduit. Now tell me where on earth you can put these 10 runs in one conduit. Cable tray, but you don't have to do it. Let's just assume we're going to put all these conductors in one conduit, all of them. I have 10 of them. 10 times 3 is what? 30 carrying conductor. The neutral counts 0 because the neutral no harmonic. Did you guys hear me? I decided to put all these 10 circuits in one conduit. Cool? Everybody's okay with that? Normally you would never do that. You put them one circuit, three phase and neutral, and one conduit. Three phase neutral, one conduit. 10 conduits, 10 circuits, 4 conductors in each circuit, 3 each. Done. Okay, so that's what we normally would do. But I decided to spice it up so I can derate. I need to derate based on temperature, and I want to make things more interesting. I want to tell you that I need to derate also based on temperature and based on bundling. Okay, so I just want to remind you guys, my calculation is 3-aught. Let's start with the 3-aught. Let's go back here and say example 2, example 3. Let's assume that whole scenario that I did right here before, 2000 amp and 4000 amp panel, the panel, and we size the conductors. We have 10 sets of 4 conductors, each one of them 3-aught. This guy, I want to spice it up by telling you that I put it on well, on a 50 degrees. I like 50. Let's use 40. We used 50 last time. 40 is too small. Let's use 60. 60 degrees Celsius. And also, all in one conduit. All in one conduit, if you can find it. All in one conduit, if you can find it. How many conductors then? I have 10 times 4, 40. But how many carrying conductor out of them? Well, the neutral is not counting because these are panels. The neutral at that level is not carrying current, it's carrying just the balance. So I have 10. Oh, I'm going to say the first thing you need to do is carrying conductor equal 10 of them times 3 because the 3 phase equal 30. Okay, so now I know that I have to do it based on 30 current carrying conductors and also temperature. Let's go do that. Right? Let's go do that. What is the question is? The question is, can you please go size me a cable? Size a conductor based on these circumstances. Size the conductor based on these circumstances. Based on these circumstances. Based on these, remember, we started with 3-aught. Based on these circumstances, we need to size the conductor. Oh, come on, let's go close it. Okay. That's how I do it. Always start. So what the question is? Size, feeder, conductors. This is really the question. All right, so let's go ahead and do it. The first thing we're going to do, the first thing I want to start, just to compare what I did there, I'm going to do the same thing with 10 runs. So I'm going to start with my 2000 amp divided by 10. Why do you think I use 10? Because I want to compare it with what I did previously with the calculation, right? That's really the only reason why I'm going to use 10. So what would that give you? 200 amp. Now, actually, for all practical reasons, now, forget about the 4000, forget about all the 2000, and you're looking at a conductor to carry a 200 amp under these circumstances. That's all what you're looking. So, did you guys hear me? We summarized that, we decided to have 10 runs of them. So, for all practical reasons, I'm only looking at one conductor that can carry 200 amp grouped together with all his buddies under these temperature. So I don't need to look at after that. I don't need to look at the 2000 because I'm only looking at one of them to carry the 200 amp. Okay, cool. Let's do that. So the first thing you need to do. So that's the 200. So let's go back to next. So I have my 200. Divide. I have a load. I need to divide. What is the current carrying conductor factor for 30? No, for 30, it's 45, right? Everybody? Yeah, 45. 45, everybody see that? 45% if you have 30 or more.
Are you in the code book? Or
I'm in the code book.
Oh, okay.
I'm in the code book. I'm in the code book. If you have 30 carrying conductors, 45. So the first you divide by 45. Next, The temperature. What was my temperature? The temperature was 60. Only a fool will do these two at the same time, but we're going to do it anyway. 60. What is the derating factor for 60? Everybody came up with 0.71? Derating factor. This is from page 310.15b2a. 310.15b2a. Yes, no? 60. You under 90-degree column? Come on, somebody. 0.71? 0.71. 0.71. Okay. Where's your calculator?
Yeah.
What? Did you guys find 0.71 from 310.15b2a? Huh? 0.45 is coming from the bundling, table 310.15b3a. 3a, can you guys there? Can you see for 21 to 30, the derating factor is 45, right? Okay, cool. So let's go divide these. Did you do it, Chris, for us?
625.9.
How much?
625.9.
626 amps, right? 626 amps, give or take. Wow, is that right? Oh, 0.71. We went to 310.15b2a. 2a. Go one more back. Here you go, right there. The one on the left. No, the one on the left. Now I'm sorry, on the right. Where's your right and where's my left? Okay, yours will be left. Mine will be the right. Right there. Looking at my left and my right.
So you're using the 90-degree
Yes.
column at 60 degrees.
Yeah, cha-cha. Cool? Everybody's there? Got that? Anybody verify that 62? 626, right, Phil? Did you verify that? 626, actually? Okay, cool. Now let's go size now. 62.6. Don't ask me to parallel again here, please. Based on 310.15b16 under 90-degree column. What's the conductor that can carry this amps under 90-degree column? 90 degree. Remember, we're derating. We size based on 90 now because we're derating. And copper because Chad is vested in the copper companies. 6. I have 1250. Anybody came up with something different? 1250. 615. The next one is 1250. So a big fat boy. 1250 kcm. 1250 kcm. 1250 kcm. But remember, look how many derating we're doing. So we went from 3-aught into 1250. Now, you really need to custom design 40 conductors, 1250 each in one conduit. That will give you probably a foot diameter, or maybe even radius, 2 feet diameter. Okay, but we're assuming 250. Okay, that's it. That's how we do it. Obviously, you're not going to do that on a feeder like this. That's why you wouldn't do a feeder like this, guys. You wouldn't group them. So let's go and see if the calculator will come up with the same answer, would I? Shall we? Any question, guys, first about the calculation? Any question about the calculation? Yes, sir.
How come you don't count the neutral?
Good, very good point. The neutral is only counted if it's carrying other than the unbalanced current between the three phases. That other than unbalanced current, we only carry it on branch circuits. They carry the harmonic. Harmonics are generated by ballasts and so forth. Now at a feeder that level, the harmonics are minimized because you have air handling unit and you have so many loads. So long story short, when you go that level of, like, what was it, 2000 amp level, the neutral at 2000, the harmonic at the 2000 level will be mitigated by the nonlinear load and the linear load together, and it's not an issue. Now, if you decided to make it an issue, Then you have to go, what do? You just change this one to, instead of 0.45 to 0.4, right? To account for the 40. But I can tell you, at this level, if we were doing branch circuits, I would. But if I'm doing a feeder that high, I wouldn't count it. Any question, guys? And the code says if it's carrying harmonic, so it's your judgment. Branch circuit definitely carrying harmonic. Feeders, they will carry harmonic, but they will be mitigated with non-harmonic loads, and there are studies by IEEE that these two together, they neutralize each other. Okay, so let's go use the calculator. Anybody use that to find what we did? All right, so the first thing we need to do, guys, I want to make sure set my calculator to 90. Everybody set their calculator to 90, right? Set 90. I want to remind you that forget about the 2000 now. We're dealing with what? 200, because we already decided to parallel. So let's take a 200, 200, and put my amps. Cool. Everybody's okay with that? Let's go change the temperature, ambient temperature. So how do we change the ambient temperature? We're going to put, what is it? Hit 66, 0, and you have to hit set and 2. So I told the calculator, you put the 60, then hit set 2, number 2. And that will set your calculator to 60 degrees Celsius. Okay? Everybody is at this point? Cool? When you reach this point, you have to go hit wire size. Here's the wire size up to this point. Your wire size, if it's only about temperature, this is what you're going to get, 250. If it's only about temperature. But it's not about temperature. We have also conductors, right? So let's, at this point, how many conductors did we say? 30. 30. And I'm going to go hit set and hit the rate size. And guess what you get? 1250. So we must have done something right, huh? 1250. Now only a fool would do something like this. But
we get it to compute the conduit size, or is it going to fall into
conduit size, you have to switch. You have to give it THL chat. Conduit, we'll do that conduit in a second here. All what you have to do is give it, what are you going to do for that 1250? You're not going to find a conduit for that size. Guaranteed, 3, 4 of them. You're not going to find a conduit. But if it's 4-aught, you can. Okay, any question, guys? Any question? So Tao, my friend, can you see how that little tool in your hand becomes very handy?
What conductor goes up to 1250
X HHW, I believe. So they look at 310 dot. What is that table at the end? They shifted them on me. They tell you the sizes that they go over.
Oh, yeah. You got
XH, does it? Okay. So I thought this baby should go. Okay. Any question, guys, about this? Everybody knows how to derate based on temperature. But do you see, Rob, my friend? You see, guys, when you parallel, first you have to make up your mind how many we need to parallel, and then you derate. And oh, by the way, if you are paralleling, it is not a good idea to group them all in the same conduit. Any question, guys? Okay, 250. Hit 30, type 30, and hit set and PAR size, this button here. Get it? Okay. So we all got it. Our calculator is working. Any question, guys? Any question about that? So I want to remind you guys, the whole derating based on this calculator, it does it the right way that we always do. Start with load, find a conductor. Start with load, find a conductor. Always start with load, find a conductor. Okay, one more example, and then we'll move to the calculation for good. This is example number 3, example number 4. Example number 4. Give me 1 second here, buddy. Otherwise, I'll be yelling at you. 300 amps, and this is a panel. Okay, 300 amp panel. And the temperature here, let's pick a temperature that's outrageous. Temperature here, we didn't use 70. The temperature here, 70 degrees Celsius. Somewhere in the heater. So yes, Oladipo. We already did the calculation based on continuous. Remember, we came up with 3-aught based on continuous. Right? Oh, wait. Let me go back here, here, here. Oh, when I didn't multiply this by 1.25. Yeah. Good point. Because when you go between panels, guys, the 1.25 factor is already incorporated in the load. When you decide, here's what happened. When I decide I need a 2000 amp panel, when I decided I need a 2000 amp panel, I already did all my load, multiply the continuous load by 1.25 plus the non-continuous load, add them all up, and made up my mind that I need a 2000 amp panel. So the 1.25 factor, when you go, especially panel to panel, already incorporated in there.
So what are you saying? If we are creating this panel to panel, we need.
If it's not incorporated, most of the time, Abolido, I want you to get into the habit of when you make up your mind about the panel based on overconduction device, you size the conductor to match the overconduction device. That's always what we do. Now the question is, your question should be to me, Chad, how the heck did you come up with this 2000 amp? I tell you how. I took all my continuous load here, multiplied it by 1.25, plus all my non-continuous load here, add them up. I came up with 1,950. What's my next overconduction device? 2,000. I didn't walk you through this calculation, but it's coming when we do the load calculation. But the minute that you set your mind on the panel size, these are panels. See how we move from panel to panel. The minute that you set your mind on the panel size, you match the overconduction device when you feed it. How to get the panel size is when you start. 1.25 becomes a major part when you do branch circuit. These are feeders, feeder to feeder. You incorporate the 1.25 in the way you calculate the feeder. You're going to see it more as we go to the commercial too. Very good point. Okay, 70 degrees Celsius. My conductors are T, H, H, N. And my question for you, temperature, and I need to size the conductor under these circumstances. It's already a panel. It's panel. Now, it's already calculated the continuous load, so don't sweat it too hard. So the first thing you need to do under these circumstances, the first thing I would do, make sure you go size the feeder under normal conditions. What's the normal condition? Forget the idea that there's a temperature difference. So I'm going to say sizing under normal condition. How do you do that? Condition, not conduit. How do you size under normal condition? The panel size, the overconduction device is given to you. You're going to go directly and find a conductor. Under which column and why? 75. Why 75? We have 100 or more than 100, right? So piece of cake, Chad. I'll take the 300 amp, take it to 310.15 B16, under which column and why? 75C. Would that be 4 or 350? More than 4 So 4 conductors, 350 kcm. Let me just see if my calculator come up with the same size, would you? So before you guys, now, before you do anything, what do you need to do with the temperature? We screwed up our ambient temperature. You need to go set your calculator and change and clear all. X. Set X. Very important. Otherwise, remember, Dustin, how yours got screwed up with the ambient? You should only be able to see 3-phase 60 cover, right? Before you start. Okay, I'm going to go change myself to 75 though, because my amps, I'm sizing based on 75. So go set 75. I'm telling the calculator, go use 310.15 B16 based on 75. Why 75? Because because the amps are higher than 100. So I default to where? 75. And I'm not derating. I am not derating yet. I'm not doing any derating. Okay, so I set my calculator. The rest is piece of cake. You put your 300 amps and you hit your wire size and up it goes with 350, right? Is that what we got? 350. Now this is actually, I have not derated yet. So the minimum that I can use, guys, is 350. No matter what the rating tells me, my minimum is 350. Now let's go, the next, it becomes next, do I need a higher conductor size or should I stay with 350? That's what the next calculation is going to decide. Okay, so let's do the second one as sizing based on the rating. So no matter what, you can't go lower than 350 because that's what we size normally. Okay, so based on this one, guys, what's my load? 300. Okay, my temperature is 70. That's a heck of a hot. What's the derating factor for 70 under 90-degree column? You're going to go to 310.15 B2A, 70. Everybody came up with 0.58. This is in page 150. For 70 under 90, 70 row, column 90, you should be able to come up with 0.58. Everybody came up with 0.58? Cool. Okay, so divide this by what? 0.58. Now, Nick, why do we divide? Because we have a load and we're sizing a conductor. That's what we normally do. If we have a conductor and we need to find a load, we multiply. But that's not what we normally do as designers. We start with a load, we find a conductor. We rarely would ever at Mashad Kuli Erickson will ask you, here's a 4-aught, can you find us how much amps you can pull out of this? It's sitting right there and we need to tie something to it. Could happen, but rarely. Usually, I need a 200 amp panel, find me a conductor for it, right? Okay, so I need a friend to give me the answer. 5? 17 amps. And feel free to approximate 0.5 up, less than 0.5 down, right? 517. Okay. Now we're going to take this one to the same table, 310.15 B16. Under which column and why now? 90. We're derating. Under 90-degree column. And now from this, who's going to be my friend to give me the answer? 517. Look, did you see the temperature? Did you see the temperature that we gave you? 70. You know what 70 is? 70 is as close to the Lord's hell as you can get.
700.
Have you been in 70? Anybody encountered 70? Does it get 70 even? How much? 700?
Yep.
Did you guys come up with 700? 517.
Yeah.
520, 700. Thank you. So my conductor should be 4 conductors, 700 kcm. Done. Oladipo, ask yourself, is the size that I came up with more than 350? Yes, we're okay. If you came up with 250 here, you cannot go size a conductor less than what the normal condition is. Very, very important. So for most of the application, Rob, that step in blue that I told you, it's really worthless. for all practical reasons. But there are circumstances, and I've seen it done, where you can do the derate and you end up with a conductor higher than what you should have used to start with. So most of the time, if you have a derating problem, this answer here will be the size here will be bigger than the size here. You're okay. I would say 95% of the times. But there's that 5% of the time, they stick it right into the master exam for you. That 5%. Any question, guys? Let's go to the calculator, see if we can come up with the same answer, huh? All right. So first thing, clear your calculator. Clear. Hit on. I want to go set myself to 90 because I'm derating. So hit set 9. Everybody has set 9. Make sure your calculator read 3-phase 90 copper 0, right? Okay, what's my amps that I want to start with? I started with 300. My 300 amps. I'm going to go hit the amps. Care less about the voltage. For all practical reasons, the voltage can be anything up to 600 volt. So this is my amps. The second thing I need to change is ambient temperature. What's my ambient temperature? 70. So you're going to go set and 2. Why 2? If you guys look above 2, it says ambient. So I told the calculator, oh, by the way, we're boiling here. We're sitting at 70 degrees Celsius. And when you're done, you're going to hit wire size. And what do you get? 700 kcl. Any question, guys? Any questions? Now, if you are to bundle, all what you have to do is just add how many bundle and hit set, derate, and it will size based on bundling too. Any question, guys, about that? You guys think we killed that derating business? Do you guys have a good grab on it? The reason and you guys have done it before, I don't take a conductor and derate the amps. You guys have done that with Gary. Take a conductor, multiply by 0.5, 0.6, this is how much amp I can do. That's not what we start. We start with a load, up the amps, go size conductor. So that's what you're going to be doing. If I give you a conductor right now, Chris, and I say, here's a conductor. This conductor can carry 50 amps on a 90, and here's the derating factor, 2 derating factor. What do you do to find how much amps you can suck out of it? Multiply and find the answer.
Although, if you're in the real estate market nowadays, they're doing a lot of building conversion. You're especially turning schools into something else. And it's not uncommon to do a study of what the facility is capable of providing without modification, and then you start adding the modification. Yeah, I'm used to doing this with telephone. People bought new telephone systems. They're typically moving into a building that was used for something else. The very first thing they do is go assess all the cable trays and what you can do, what you can put in there.
Absolutely.
So there is a lot of reverse stuff.
Reverse function. Let me just confess a little bit about this calculator, guys. Up to my knowledge, if you were to tell this calculator, here's a 500 kcm, the temperature is 50 Celsius, and I have 16 of them. How much current they can carry? The calculator cannot do that for you, up to my knowledge. Did you guys hear me? Cannot do that for you. It always starts with the load, the way it's meant, exactly how designers do. Start with the load, find the conductor. At least up to my knowledge. I don't know if there's a couple of other functions I haven't hit, but disclaimer, up to my knowledge. Okay, I'm going to do 2 more examples. And these are about tabs. I will talk about tabs in details, guys, but 2 tabs dear to my heart. They're sizing tabs that I'm going to talk about. Example number 4, and we use the calculator as one. Example number 5. Suppose I have a 500 amp feeder, and suppose my feeder This is my disconnect switch. This is my mist gutter. Gutter, not your rain gutter. This is a gutter where they have conductors and you tap into them. Similar to these surface mounted gutters, you have conductors with a cover, you cover them, you extend the equipment. And this is a disconnect switch, 500 amp. And right in here, bud, I tapped, look at that, just tapped. And I went and I fed some equipment. 1, 2, 3. Okay, and these are my equipment. Here's a box, and another box, and a third box. All right, so let's go ahead and do the following. So this is the cheapest system that you can design when you use a gutter. Engineers hate it, contractors love it because it saves you equipment. So what I do is I take a fuse disconnect, throw it on the wall, pull a 500 amp cable, put it in a gutter, tab, instead of having a panel, just cable with an enclosure called gutter, tab it. When I say tab, guys, splice, basically big fat splice. I splice the cables in it, phase A, phase B, phase C, neutral, ground. You tap them and you go to each one of these disconnects. So I can have rooftop unit 1, rooftop unit 2, rooftop unit 3, and these are just disconnect sitting there and feeding equipment. I'm not showing the equipment.
Why do engineers hate it?
Well, this is not reliable. If you have a short circuit here, what happened? You lost 3 pieces of equipment. From a reliability point of view, if you have any short circuit, ground fault, malfunction from this point up anywhere in the system, you lost the whole system. So who cares if your system needs reliability? Data centers, hospitals, sport arenas, you can't lose heating, cooling the building when you have thousands of people there. You better have what they do. Then engineers, they grab these circuit breakers and put them in a panel. A panel is more reliable than a gutter. That's what it is. And there's limitation on how far you can go from here to here. We'll talk about the limitations. There are 2 limitations. There's the 10-foot rule, guys. I'm going to do this one as from here to here, 10 feet. And from here to here, 10 feet. And from here to here, 25 feet. So I'm going to do two of them 10, 10. You know what I'm talking about here? Distance between the circuit breaker, this equipment, and this equipment, basically. We don't go right inside the equipment, between the 2 equipments.
What's the difference, the distance? Or why the 10 versus the 20?
The code has 2, it goes based on 10 or 15, they allow you to use a smaller or bigger conductor. It's only the difference. You're going to see in a second here. Okay, any questions about this? Why would we tab? Save money. If you tab, is there any, what does tab mean? Everybody knows what a tab means? A tab is you take number 16 conductor and tie it to number 12. It's a tab with no overcompression device. You take a 500 conductor and physically, mechanically tie it to a 2000 kcm conductor. That's a tab. Every time you tie a conductor to another conductor that's different size, that's a tab. If you tie it through a circuit breaker, it's not a tab. If I have 500 amp, I put a circuit breaker right here, tie it to it, 200 amp, and put a feeder after the circuit breaker right in here, that's not a tab. But if you can see it, is there any circuit breaker from this point up to this point in this feeder, the 10 feet? No. Fuses? No. The next fuse is located right here for the feeder. Okay, so that's my tab. And this feeder, I will remind you, that's a big feeder, big conductor compared to the others. All right, so let's go size. There's rules for the tab. Rule number 1, these conductors have to be protected from physical protection. You have to put them in a conduit. Rule number 2, they have to be terminated in an overconduction device that protect them, meaning if this cable is 100 amp, this overconduction device cannot be more than 100 amp. This cable is 200 amp, this overconduction device cannot be more than 200 amp. And they can't go more than 10 feet based on the rule, or 25 feet based on the rule 25 feet. And the last thing, the conductor size right here, this is probably the most important thing. If it's 10 feet, the conductor size cannot be less than 10. I'm going to write it this way so you guys can write it here. This conductor size have to be more or equal to 10 times overcurrent protection device, which is this baby, overcurrent protection device. These are the rules. Very easy. If it's 10, okay? If it's 15, if it's 25, this conductor can have to be more or equal to, this is 1/10, 1/3. 1/3 times overcurrent protection device. Done. 1/3 times overcurrent. Where's the overcurrent protection device? Right here. That's how we size these conductors. So what's the advantage of the 10 over the 25? The 10 can get you a smaller conductor tab, right? 1/10 of a number is smaller than 1/3 of a number, right? I hope, right? Everybody knows that. Why 10 is better than 15? 25. Number 10 allows you to tab a smaller conductor from a bigger conductor than 25. Okay, with me, guys? So these two tabs have to be, the conductor size have to be more or equal to the overconduction device, 1/10 of the overconduction device.
Is it a tenth of the physical size or the ampacity?
A tenth of the, they call it long time pickup of the circuit breaker. So if this is a 500 amp and sit, because later on these can be adjusted, guys. If it sit at the 500 amp to trip, then you multiply by 500 amp. If it's ampacity, oh, yes, okay. The ampacity of the overconduction device. All right, let's go size these conductors. So I'm going to give you numbers, guys. So help me size them. I'm going to call this baby here. I'm going to start with this. I'm going to call it number 10. Oops, number 1. This is my number 1. Doesn't even look like a number 1. I'm going to call it number 1. This one I'm going to call it number 2, and this one I'm going to call it number 3. You guys have any issues with that? We're going to go size them based on the tab rule. I'll just call them 1, 2, 3, and I'm going to go size them in the next page. Any question? Physical protection for them, no more than 10 or 25, depending on which one of them. The conductor size minimum can be 1/10 for 10 and 1/3 for 25. They also have to be terminated with an overconduction device, a fuse or a circuit breaker. Must. That match the conductor amp or higher. Oh, match the conductor amp or lower if it's overconduction device. Let's go size them, would you? Okay, so let's go start with number 1. So number 1, as you can see, conductor size. Conductor size, it says 1/10 times the overconduction device is 500. What would that give you? 50 amps. Right? The minimum, that's the minimum conductor is 50 amps. The minimum conductor is 50 amps. Okay, cool. Cool, 50 amps. 2 things for this conductor. So I need to go find myself. So take the 50 amps, take it to 310.16 and 310.15B16. Now, if you're doing tabs, most of the time, guys, when you do tabs, all the conductors, all the terminals are rated for 75. So yes, if I don't know, I have to go rate this one based on which? 60. But I'm going to tell you with tabs, can I put a disclaimer? With tabs, if you're doing tabs, you're a big boy or girl. So termination, all terminals are 75 degrees Celsius rated. 75 degrees Celsius rated. 75 degrees Celsius rated. Okay? Did you see the disclaimer here? That's why I'm going to go size this one based on what? 75 degree column. How about if you guys can give me a conductor 75 degree column, will you? 75. Number 8. Otherwise, it has to be number 6. Otherwise, it has to be number 6. Number 8. So that will be 4 conductors, number 8. Okay, let's use a calculator as long as we're on it, right? Well, before we do that, let's put the overcurrent protection device on it. The overcurrent protection device from this conductor, the overcurrent protection device. So this is just a conductor size, overcurrent protection device to land it on it. It has to be 50, right? What's the next 50 or next standard? 50 amp. So for this, you go to 240.6. So look at the 50 here. You need the next standard up. What's the next standard? It's already a standard here, so we don't have to mess with it. It's 50. So if you go back here, this guy is going to be 50 amp, and this conductor, we already calculated that conductor. So the minimum conductor, guys, the minimum conductor that you can land on this system, the minimum conductor that you can tap at 10-foot rule is a number 8 conductor, and you can land it on a 50 amp circuit breaker. Remember, the terminations are rated for what? 75. If it wasn't, then it will be number 6. If it wasn't, then it will be number 6, and the overcurrent protection device will be 40. But most, 99% of the time when you tap, all the conductors and equipment rated, big stuff, rated for 75, good to go. Okay. Now knowing this, that's the minimum. Now knowing this, here's what I want to change slightly here, guys. Knowing this, so the minimum, I'm going to go, can I tab, so the minimum is like is 50 I can tab here. Can I tab 100 amp? I'm going to put 100 amp here. Is it okay to put 100 amp and 100 amp conductor from this system? Yes, because 100 more than 50. So that whatever conductor I size right here is going to be always more than what? More than 50. So I added, for this one, just to spice it up, I decided, Chad Curdy, based on that's the minimum overcurrent protection device and cable I can put here. So I really want 100 amp disconnect here. So I put 100 amp. So let's go size that second one. Number 2. I'm sorry, 2. It's going to be sizing for a 2. What is it? 100 amp. I said 100 amp disconnect. 100 amp overcurrent protection device. Overcurrent protection device. Okay, so you take the 100, take it to 310.15 B16, 75 degree. Why 75 degree? Because I'm telling you all the terminals are 75. What do you get? Number 3? Number 3. Thank you, sir. Number 3. That will be 4 conductors. Number 3. Can I verify this one, guys, quick with the calculator? The first thing to verify with the calculator, remember my calculator is already screwed up here, so clean. I need to go reset my calculator to 75. Why 75? I reset my calculator to 75, so basically size everything now based on 75. The first one was 50 amp, wasn't it? 50 amp, hit 50, put your amp, and find the wire size. What did I do here? There's ambient temperature. You guys see how I came up with 2 watt? I did the same mistake that you did, Dustin. So I need to go clear my calculator because there was an ambient temperature. Make sure you clear your calculator, guys, and see 3-phase 60 copper. Clear your calculator, set clear. Next, set to 75. So I'm sizing based on 75. I'm going to do the first one. I see if I can get up with 50 amp. So here's my 50 amp, and I'm going to go hit wire size. What did I do? I didn't put 50 and hit amps. I didn't hit the amps. And then wire size. Number 8. Did you guys come up with number 8? Okay, so we verified that this is number 8. Let's go back to the second one. Oops. Forward to the second one. Second one was 100 amp. 100. Put your amps. What's the voltage? Careless. And hit your wire size. 3. Now suppose that you want to size it based on 60-degree column. So look how easy that would be. All what you have to do is just hit set and hit 60. Where's my 60? 60 here. I came up with number 1 based on 60. But we all know that it was based on 75 because I told you so. Well, that would be number 3. Any questions about that? The last thing before I let you go eat is the 25 foot. Let's do the 25, right? We did these two. I hope you understand, guys, when I did these, this one was the minimum that I can use. This one was more than the minimum. That's okay. I came up, my minimum conductor size, guys, came up with number 8. But can I tap number 3 if my minimum is number 8? Duh, Chad, of course. Number 8. What's my overcomputation device for this number 3? 100 amp. It's already given. All right, let me do number 3, guys. 3. Oops. 3. Size for 25 foot tab. Okay. The 25 foot tab, the rule for sizing, guys, is you take 1/3 and you multiply it by the overcomputation device, which is what? 500. What's a third of 100?
166.
And is there a 6 to it? 166.
166.
166 with a, doesn't it go to 1666?
Yeah, it's gonna have a pop.
I'm just gonna go 167. Yep, 167. Right? 16 because it's more than a half co-op. 167. This is the minimum conductor size that you can size. You can pull 25 feet minimum. Okay, let's go size that baby. So 167. I'm going to go take 167 amp, take it to 310.15 B16. Under which column? 75. Why? Because it's more than 100, and I also am telling you it's 75 terminals. What would you get?
2.
Number 2. 4 conductors or aught. 2 aught.
2 aught.
2 and an aught. 2 aught. 4 conductors, 2 aught. 4 conductors, 2 aught. 4 conductors, 2 aught. Any question, guys, about that? Let's go do the calculator, see if we can come up with the same answer. Am I set at 75? Yep, everything is okay. Clear your memory here. Take the 167, right? And hit the amps and hit the conductor wire. And what do you get? 2 aught. Surprise, huh? 2 aught. The last thing, guys, is find the overcomputation device. You have to land this conductor on an overcomputation device. So I think if you hit twice, it gets you the amp of 2 aught. Yeah, if you hit it twice, it gives you the amp. So my amp is 175, right? Is that the amp for 175 for this conductor? 2 aught is 175. Now, then I have to land this, I'm going to size the overcomputation device for this. So let me, how am I going to say that? I'm going to do it right in here so it will be all the same. Size over current protection. Well, let's do it in the second one. All right. There you go, Chad. Okay. Size over current protection device for 25 foot tab. I'm going to remind you guys that the conductor that I use is what? Which number is that? I use number 2 aught. Number 2 aught gave me 175 amps. So my overcomputation device cannot, shall not, will not be more than 175 amps. So my overcurrent protection device, my overcurrent protection device must be equal or less or equal than 175. Okay, so what do? You take 175, take it to 240.6 from NEC 2011. What's the next standard? What's you have to go down, by the way. If it's not a standard, you're going to go down here. So is 175 a standard fuse or circuit breaker? If it's not a standard, what do you need to do? Down. I believe it's standard, right? Typical 175, 150, 175. So we hit the jackpot here.
Isn't the device giving us the standard?
The device.
167 amps got the wire size and it told us 170.
Yeah, but you go back to the conductor size. Or you can go to 165 and go to the next standard up. But I always first size your conductor, then go back and see how much your conductor can carry total, right? This is how much you can carry total, right? And then based on this, you size, this will be 175 amp if used or circuit breaker.
So it's not making it, it's just coincidental that
It is coincidental.
that it came out to a standard.
Absolutely. It's coincidental. What's saying is this giving, did I get that one from here? No. This could have been 173. Then you have to go down to where? 150, right? The next standard down is 150. Had this been 171, I can't go to 175. I have to go down to 150.
If you take a look at page 157 on our calculation book,
157. Okay. 157. Okay.
you'll notice some of these things have different color font with an underline.
Yep.
Is there something magic about those?
Yes. Those got changed in 2011.
I did.
Yes. Those they got changed in 2011. They used to be different. Higher. Good point. Any question, guys, about this? Yes, sir.
Please, I don't know the rules that you use in the multiplication of the computation devices capacity.
Right here,
Yeah.
these two rules, very easy. If it's 10 foot,
Is it a standard rule? That's what I want.
that's always a rule. If it's a standard rule all the time, if you're tabbing 10 feet, it's 1/10 of the overcurrent protection device. Take this. If this was 1,000, and I want to tab a conductor up to 10 feet, that would be 1/10 of 1,000. That will give you what? 100, and the conductor have to be rated for 100 amp. So you go to the table under 75. If you know the terminals are 75, size a conductor. If you don't know the terminals are 75, 100 or less, you go to where? 60. Now you go to this. If it's 1,000, you multiply this by a third. The third of 1,000 is 333.3, right? 333 amps. A third of, if you want to tap 25 feet. Do you know what a tap 25? You know. Here's equipment number one is here. You take a cable, move it 25 feet, and put the other equipment 25 feet away from it. So if it's 25 feet, that will be a third of 1,000, 333. Go under 75-degree column now for fact, because it's more than 100, and size the conductor, and that will be the minimum. Can I tab? Look at this, guys. I tab number. What was I here? No, I tab number 8 here. Can I tab number 2, number 1, number 5, 4 out? No problem. That's the minimum conductor size. Do you guys know why they do it this way? Because if you tab a smaller conductor and you have a short circuit, your conductor, copper or aluminum and insulation, it will heat up and it will evaporate, especially the aluminum, completely evaporate under short circuit condition. It will completely melt and evaporate. Before the circuit breaker wakes up, it will wake up, but by that time, everything will be mingled together. That's why they want to have a minimum conductor size that can handle short circuit. And we'll talk about the short circuit rating as we go through the industrial, guys. Any question? Is the calculator worth the money that you guys paid for? with all these exercises. By the way, this is the first time we ever done it this way. I usually do this part, but I don't verify with the calculator. So that's all what I have. Any question for Chad? Any question, my friends? Thank you.
You said we should be making the temperature to be assumed as 75 when you tap.
If you're doing tab with gutters, 99% of the time, the conductors, the gutters, the lugs, everything is rated for 75. If you don't know though, you use the rule of the code. What's the rule? 100 or less, 60, more than 100, 75. That's kind of cover your bottom type of rule. Okay, thank you guys.